Good morning, or good afternoon, or good evening, everyone, wherever you are joining from. So welcome to this book release event. We are very excited that our book, Sustainable and Resilient Engineering, Drivers, Metrics, Tools, and Applications, published by John Wiley, is released today. We are so excited about it. I know some of you have ordered the book and it is in your hands. So I'm one of the co-authors of this book. So my name is Krishna Reddy. I'm a professor of civil and environmental engineering at University of Illinois, Chicago. So I teach a graduate level class on sustainable engineering, and I also teach undergraduate class on engineering for sustainable communities. So I use this book as a textbook, and I also integrate sustainability and resiliency in my research. My research is focused on environmental remediation, waste management, and in general, infrastructure engineering. So with that background, I pass on to my co-author, Claudio Canasegli.
Thank you. Yes, my name is Claudio Canasegli. I am a professor in the University of Vigo in the Department of Chemical Engineering. I've been teaching there for about 30 years, and I have experience in the field of chemical and environmental engineering, and more recently also in sustainable and resilient in engineering projects. I joined this project because I was very interested in develop my career in this field. And I really appreciate the collaboration with Professor Krishna and also with Dr. Adams in this project, in this book that was the result of a long and intense work during the previous years.
Now on to our other co-author, Dr. Jeff Adams.
Greetings, everyone. My name is Jeff Adams. I'm a principal consultant with NGO Incorporated. We're a mid-size earth services, earth sciences, engineering, and consulting firm based in San Ramon, California. We have offices throughout the throughout the West Coast of the United States, as well as the Western Pacific, Australia, and New Zealand. My practice for the better part of 25 years has focused on environmental remediation to facilitate real estate redevelopment, primarily brownfields. Ultimately, one of the great sustainable approaches that we as engineers take part in from the standpoint of land recycling. I also work within the realm of resiliency and have an expertise in geologic hazard abatement districts, which is a creature of California law that allows communities to take on efforts to self-insure and to undertake improvements to prevent a range of geologic hazards. For the better part of the past 15 years, I've performed research throughout the realm of sustainability. And over the past few years, I've also taken on some research with respect to public administration and institutions to ensure resiliency through our communities. Professor Reddy?
Yeah, with those introductions, now you know who the co-authors of the book are. And we have a brief presentation. And then let me share this slides. And then at the end of the presentation, we will be very happy to answer any questions that you have. So again, I'm very, very excited about today. We have been waiting for this day for a while. So our book title, as you see here, Sustainable and Resilient Engineering, Drivers, Metrics, Tools, and Applications. So you can, find this book on Wiley website, and also you can find it on Amazon and other online platforms. So today, very briefly, we want to present a survey we did in, I think last month in July, about teaching a course on sustainable and resilient engineering. So I want to present that results. Then after that, we will introduce the content of our second edition of this book. This is actually a second edition. We had a first edition. We made substantial changes to the first edition. And we will go through the content of this whole second edition. And then we will present how this book could be useful as a textbook. and what are the resources that are available for instructors who wants to teach such a course. And then at the end, we want to present how this book serves not only as a textbook, for students, but also as a valuable resource to researchers and in particular industry professionals. So then at the end, we will have a question and answer session. So as I mentioned, we did a survey in July. We organized a short course at University of Vigo in conjunction with conference EGRWSC 2025. And so the purpose of the survey was to understand who is teaching courses on sustainable and resilient engineering, what are the logistics, what are the challenges in teaching, both at undergraduate and graduate level. And it was a quick survey. So we had 50 responses. As you see from here, we had respondents with different backgrounds, majority of them with a civil engineering background. And you can see their teaching experience. I think many of them are academics. And you can see, people with extensive experience and, people who are early career in teaching. And we have a broad spectrum of respondents. And then we asked them a question, do you currently teach a course related to sustainable and resilient engineering as a dedicated course, or, do you cover some of these materials in any of the existing courses? And to our surprise, many of them don't teach a special course on sustainable engineering and don't even cover sustainability aspects in their courses that they are teaching. And then we asked, whoever were saying yes, out of 50, there were 9 people who said that they're considering sustainability and resiliency in their teaching. And then we asked them, are you teaching as a dedicated course, or you're teaching as a part of, other courses that you're teaching? And as you can see, only 1/3 of them, basically 3 out of 50, are teaching a dedicated course on sustainable engineering. Again, this is kind of, working in sustainability and resiliency. We are very disappointed that, not much is going on in terms of educating our future generations. And then we asked them what topics they are covering, and you can see a lot of topics. Environmental health risk analysis, that's like a more traditional topic that is extensively covered, but other topics like carbon footprint analysis, LCA, life cycle costing, economic and social impacts, triple bottom line, these are topics that are also covered in our book, and they are being covered in the courses that whoever is teaching it. And then we asked them, how do you test the students, for grading? And majority of them saying that they use projects. And I agree with this assertion or this approach, because, in such courses, you cannot have just questions and typical exams. So projects would be the best way to learn and gauge how much students have learned. And then we asked them what kind of sustainability assessment tools are used in the class they teach. So some of them responded, CIMA Pro, One-Click LCA, and some people said they have their own spreadsheets that they developed. And majority of them, they said they don't use any assessment tools. Again, that is kind of disappointing. So that's where our book comes into good use. We talk about sustainability assessment tools that can be used in teaching and in practical applications. So we asked them, what references they use. Whoever is teaching, they use scientific publications, basically like a journal papers and other things. And some of them use our first edition Sustainable Engineering book. So we are very happy about that one. But I think those who use our first edition, they will find second edition to be more attractive. So we asked them, what are the challenges and barriers in teaching sustainable and resilient engineering? As you see, the top one being the lack of expertise or necessary interdisciplinary background, and the lack of awareness or urgency in learning about sustainability and resiliency. I think, and lack of having a proper reference materials, particularly like a textbook. And last two, I'm happy to see that because people seem to know, the scope of sustainable and resilient engineering. And I'm particularly happy that, curriculum is not restricted to offer a course on sustainable engineering if somebody desires to teach that course. So, so we are very happy that our textbook can address all these challenges and barriers that this survey respondents pointed out. So that is the summary of the survey. So there is a lot of scope for developing a course and teaching a course on sustainable and resilient engineering, and our book will be very, very valuable. And then right now, you want to know what is the content in the textbook in this book. So we will introduce the content of the second edition textbook. And so the textbook has four sections, and the first section is going to be covered by Jeff.
Thank you. So section one of the four sections, the idea is to introduce the concepts behind sustainable and resilient engineering and some of the key drivers that are affecting these areas of focus. Some of these include climate change, pollution, depletion of natural resources, urban sprawl and their effect on food and water scarcity, as well as the loss of biodiversity, economic inequalities, and social injustice. And the idea is that we need to look for solutions for our engineered systems that integrate sustainable and resilient approaches to solve these problems. So section one consists of 5 chapters, and I'll describe a little bit about each of them. Oops. So chapter 1 again introduces the concepts, the drivers behind sustainability and resilience, with specific objectives to provide examples of emerging challenges that require a focus on sustainability and resilience, as well as definitions behind sustainability and resilience and how these two concepts are different, but how they work together as well, and the importance of integrating these towards sustainable development. Chapter 2 focuses more on environmental concerns with respect to the sustainable triple bottom line of environmental, economic, and social dimensions, and how these affect our decision-making towards engineering systems. Some of the specific objectives include the identification of the major issues, as well as their scale from global to local scale, highlighting the impacts of how these can affect the environment and communities, as well as populations. And the intersection of these 3 dimensions and how we need to find holistic solutions to solve these problems, with the idea that we need to promote a balance between environmental protection, economic development, and social protections. Chapter 3 dives further into social, economic, and legal issues with how these systems interact, providing an interaction and a basis for both financial and environmental systems and dimensions towards these solutions. Some of the specific objectives include highlighting the importance of social indicators to start to measure well-being and equity among populations, frameworks to actually accomplish this, covering specific economic aspects, including life cycle costing and true cost accounting, to evaluate long-term sustainability for engineered systems and potential solutions, as well as a greater focus on environmental, social, and governance reporting for businesses and for projects and how they can sustain and drive sustainable business practices. Chapter 4 looks further at natural resources and how populations use and exploit and potentially deplete these resources. We highlight the growing demand across the board of all natural resources, be it minerals, be it forest products, be it food stocks. And we discuss the environmental, economic, geopolitical implications of resource depletion with concepts such as overconsumption, population growth, and unsustainable extraction approaches. We also discuss concepts of overshooting and urban metabolism and how circular urban systems can drive sustainable outcomes to preserve these resources. In Chapter 5, we look a little bit further at disaster resiliency and the importance and the differentiation from sustainability. By doing this in greater detail, we focus on how resiliency plays and interacts with the growing effects and impacts of climate change, resilience concepts, as well as policies and how we can drive more resilient outcomes for infrastructure and for engineered systems, as well as frameworks and case studies that describe real-world examples that are able to incorporate this. With that, I'll turn it over to Krishna, who will describe section 2 of our textbook.
Yeah, as in the first section of the book, basically we talk about drivers for thinking about sustainability and resiliency. We define what is sustainability, what is resiliency, and the triple bottom line: environmental, economic, and social. And with that understanding, the goal is to incorporate sustainability and resiliency in your engineering projects. So a lot of times, people use sustainability and resiliency as buzzwords, but it's not just saying it, but prove that, your engineering design or systems are truly, sustainable and resilient. So for that one, you need to quantify the sustainability and resiliency. So the section 2 is all about, what kind of metrics that you can use, what kind of tools that you can use to quantify sustainability and resiliency. Because, unless you demonstrate quantitatively how sustainable and resilient your engineering design is, nobody's going to trust you, just you're using for the sake of, publicizing, but you haven't really looked into detail how sustainable your design is, right? So this is a very important section where we talk about all the metrics and tools to quantify sustainability and resiliency. So we generally talk about, we have this chapter 6, 7, 8, 9, 10, 11, 12, 13. These are all aimed at quantifying the sustainability and resiliency. In the chapter 6, we introduce what are the indicators, what are the metrics, what are the general assessment tools that we have. So the assessment tools can be very broad, very general, to, some assessment tools could be very specific to the types of projects that, it is developed for. So and in a book like this, we wanted to talk about more general assessment tools, and then at the end give summarize some of the project specific type of tools that are there. So if you are involved in sustainability and resiliency projects and you want to quantify it, maybe the first thing you want to find out is there any tool that is specifically developed for the type of project that you are dealing with? If it is there, understand the pros and cons of that tool and apply it. That's fine. But if you don't have it, then you can use some of these general tools. So among the general tools, as I said, like you have different indicators, metrics defined. And one of the general tool is material flow analysis and material budget. This is very important if you are looking at the material balance scenarios under different conditions. And then chapter 8 deals with carbon footprint analysis. So this is kind of the basic quantification that you generally see, carbon footprint of this, carbon footprint of that. So this is the basic environmental impact that people calculate. And it's important to understand what is carbon footprint, how you calculate it, what are the standards to calculate this. So all those things are explained in chapter 8. And then if you want to quantify environmental impacts beyond carbon footprint is not important because that is causing the climate change, extremely important to control that one. But from an environmental point of view, not only greenhouse gases, but you have other environmental impacts. So if you want to quantify other environmental impacts, you have to use tools like life cycle assessment, it's LCA. And in this chapter 9, we explain what is LCA and what is the use of it, how it can be performed, and what are the pros and cons of it. So all the details of life cycle assessment are in chapter 9. And there could be some books on just life cycle assessment itself. And in fact, in some universities, there are courses on just this topic. But we try to summarize the most essential aspects of LCA in chapter 9. And we feel that this is a really good chapter for anybody who wants to learn about LCA. LCA has a lot of challenges. You don't want to give up doing some assessments similar to LCA. The streamlined lifecycle assessment is the one that you can do it very easily. It does not need any computer software, extensive resources. So this is another one we explain in chapter 10. And then, the other one is called economic input-output lifecycle assessment. In this one, you use the project budgets and the type of project that you're dealing. It's a project sector, and it's an online tool. You can use it, and you can get environmental impacts based on this. So it's good to know this tool. And then other tool is, a lot of environmental impacts are at a broader scale. Obviously, you want to look at environmental impact at local scale. You want to quantify, public health issues and ecological risk issues. So there are the standard methodologies that have been developed, and it's important to integrate those things in sustainability assessments too. And then the chapter 13, we talk about, this field is evolving, and in chapter 13, we talk about what are all the emerging resiliency and sustainability tools, general tools, as well as, very project-specific tools. So it's a really valuable chapter to read it. And with that assessment, somebody wants to think about, my assessment shows that, I am not doing good job in terms of sustainability resiliency. What can I do? What are the best engineering practices that I can adopt to make my systems more sustainable? So section 3 deals with all the best management practices, and Claudio is going to present these things.
Yeah, thank you. Yes, in section 3, sustainable and resilient engineering practices, we are going to apply the previous information in the section 1 and 2 to specific engineering projects, and we explain how to do the right thing to obtain sustainable and resilient results in those projects. So in this section, briefly, we discuss some emerging technologies, and as I said before, best practices in different fields of the engineering, including energy, materials and circular economy, land, buildings, civil infrastructure, and climate geoengineering. The section 3 is divided in 7 chapters, and each chapter covers one of the aspects I mentioned before. So beginning with chapter 14 is about the emerging technologies and how these emerging technologies can be helpful in the design or in the improvement of projects using these smart technologies such as artificial intelligence, big data, and digital twinning, and others. So with this information, we can improve our projects and making decisions with the necessary information to achieve a better sustainability and resiliency in all the projects. We also include in this chapter the design of engineering material for specific applications, the innovative storage in the energy sector, and also the nature-based solutions, because usually they lead to sustainable applications in many of the projects. Then in chapter 15 is about energy. As you already know, the energy generation has an enormous impact in the environment, but also in the society and in the economy. And here we discuss these impacts, and we present the alternative energy sources that can provide the necessary energy we need for our world, but at the same time reducing those impacts. And we discuss the different impacts of the different energy sources including the renewable sources, of course, and we compare with the traditional energy sources we use every day. It is important to consider also the economic aspects in the projects, and then we do not forget that there is something new. We include the resiliency in these projects, considering the context of this increase in climate change and global warming. In chapter 16 is about materials, wastes, and circular economy. As you know, the generation of wastes produce an enormous impact in the environment, and the good waste management may reduce that impact. So those materials, we can extract a significant fraction of material from the waste that we can reuse in the production of new products, but also we can design new materials more effective with better properties and with less impact. So all these concepts are discussed here. And again, we also consider the resiliency of these materials for different projects. In chapter 17, it's about buildings. Buildings has an enormous impact because they consume some materials, they occupy a piece of land, but they also consume a significant amount of energy. So buildings in general has an important impact. And the design of the building, the materials, and the maintenance operation is going to have an important effect in the final impacts. So we discuss all these elements, and we introduce the LEED certification that is a rating system that is able to identify the good points and the not so good points in any building, and we can reduce the impact following the recommendation of these methods. Similar to the buildings, chapter 17 is about civil infrastructure. In this chapter, we introduce the Envision rating system that basically evaluates the sustainability and the impacts, evaluates the impacts, and then the sustainability and the resiliency of the different infrastructure in several categories. And this method can be used to determine the characteristics of each infrastructure, and at the same time to identify the weak points so we can improve the sustainability and their resiliency for the future, considering, well, this global warming, climate change, and other sudden shocks. In chapter 19 is about the land. The land is fundamental for the development of the societies. We need land for build our homes, our cities, for transportation, and also to grow food. So we discuss all these aspects and focus in the pollution problems and in the remediation. Traditionally, the remediation of soil focus in the remediation objectives in removal those contaminants, but now it's even more important to consider also the wastes and the energy that we consume in these remediation processes. So basically, we have to consider the impact of the remediation process itself. So when we select a remediation process, we do not have to consider only the objective of removing the contaminant, but also the possible impact of this process. And we discuss these all aspects in chapter 19. And finally, in chapter 20 about climate engineering, well, it is important to consider or to know, everybody knows that the global, the greenhouse gases produce a global warming and climate change with significant impacts in the environment and in the life of the people, and is going to be more and more necessary to reduce those impacts. And for that, we have two different methods. One option is to remove carbon dioxide from the atmosphere to reduce this global warming, or the other alternative is to reduce the solar radiation. So we keep the temperature of the planet in the right interval. Well, we discuss the different methods and the possible applicability in a global scale. And the idea is to minimize the impacts of this global warming in a context of sustainability and resiliency. So this is the 7th chapter for section 3. And then we can move to the last section. In the last section is about sustainable engineering application. And in this section, we introduce a collection of projects. We define the project and we apply all the methods we explained in the previous section, section 1, 2, and 3, to give a solution for different specific projects. We have here five different projects that goes from water disinfection, contaminated site, highway pavement, community garden or hydroponics, and green infrastructure in the city of Chicago. And in this chapter, we apply the methods to obtain the sustainability and resiliency of each project, the different scenarios considered in each project, so we can select the best scenario considering what is the more sustainable and more resilient. This is an interesting information for developing new projects because it is explained step by step. So based in these projects, we can, all the readers, professors, students can develop their own project following the methods and the steps presented here. So now I call Professor Krishna to continue with the next step.
So one of the original motivations for writing this book was, not having a good textbook to teach a general course on sustainable engineering. So I teach a course on sustainable engineering. I've been teaching this course for several years. And so in the beginning, there was nothing, and just had information from different sources. So we tried to, assemble all that and then published first edition, and a lot of people liked the content of that one. And then, as you know, this field is evolving. And I teach a graduate level class, sustainable engineering, and students from all specialties in civil engineering take it, structures, transportation, environmental, all construction. Everybody takes that one, and not only civil engineering students, but also electrical, chemical, mechanical, all the students will come and take this one. And, now the word has spread so much that, there's so much demand for taking this course. So the reason why anybody from any engineering can take it is because in this course, we talk about general concepts about sustainability and resiliency, and we talk about frameworks or tools to quantify the sustainability and resiliency. And those concepts and tools can be applied to any field of engineering. So if you haven't, taught a course on sustainable and resilient engineering, we highly recommend you to teach a course. I'll be happy to share my course syllabus, and this textbook. This book will be excellent textbook. So not only using this book as a textbook, but we also provided a lot of resources that can help you teach this course. We have PowerPoint files, for each chapter, and in the second edition, we included examples within the text, and also we included the numerical problems at the end of each chapter. And we have provided the solutions, and these solutions are only accessible by the instructors. And then we have spreadsheets to do simple sustainability assessment. So with these resources, I hope a lot of instructors can teach this course, and of course, all three of us as co-authors of this book can help you any way you need. So The key features of second edition is we seriously thought about making this as a good textbook for teaching a course on sustainable and resilient engineering. Not only, teaching, but we wanted this book to be a good resource for professionals. And I listed, a lot of key features in the second edition that were not there in the first edition. So we clearly define sustainability and resiliency. We emphasize the importance of resiliency. How do you integrate sustainability and resiliency? We incorporated best management practices, updated on the sustainability assessment tools, so much of new information that is incorporated in this one. Especially for teaching purposes, each chapter as right in the beginning, what that chapter is all about, and we have solved the examples within the chapter. That was not there in the first edition. So when we see some difficult concepts, we try to put in a numerical example so that people can understand it. And then we have several new problems and questions at the end of each chapter. They can be assigned as homework questions. And, the instructors can get the lecture slides, the solution manual for the problems that we have at the end of each chapter. And we have example projects that deal with assessing the sustainability and resiliency. We'll be happy to share those kind of information. And the purpose of this book is not just to make it as a textbook, but we also wanted to make sure that it is useful for industry professionals, because now industry is after sustainability and resiliency. They want to integrate sustainability and resiliency in a lot of projects. There are a lot of initiatives, requirements to incorporate sustainability. So, and industry people may not have taken a formal course on sustainable and resilient engineering when they went to school many years ago. So this book would be a great resource. So Jeff, coming from industry, he can share his thoughts about this issue.
Yeah, unlike my two distinguished colleagues who have spent their careers in academics, I've spent my time in consulting. And there's obviously some subtle differences between the two and how we use references and materials for our work, our respective work. And of course, as authors, myself, speaking for myself, we're proud of what we've created. And of course, I'm going to be a little bit biased about why this is so good for professionals. But my contributions and all of our contributions have directed it where it does serve the dual purpose to inform professionals. This is an evolving, dynamic field. Many people who are practicing have little, perhaps no experience in sustainability or directly with resiliency. And this is meant to fill those gaps. Of course, students are coming out of schools right now and entering in the workforce that bring those skills. But this is meant to educate everybody within practice. And with the idea that it truly is to emphasize and show the links of the concepts of sustainability and resilience. Sustainability is a normative approach. What are we trying to sustain? What are the things in our environment or our society that we're trying to preserve? Whereas resilience has a little bit more of a direct definition about the ability of a system, an engineered system, to withstand and bounce back from some type of exogenous shock. And how do these two interact? It's very important. Key to this, though, is, of course, as a dynamic approach, engineering technology is always dynamic. There are always new technologies that are coming in that are changing the way that practitioners and those that consume those services look at the world and the expectations for solutions. So as these technologies emerge, we cover these. It can be very small, on a very small scale, or a very kind of basic approach in business models, such as a circular economic approach for materials or processes, to very large, perhaps even controversial approaches for climate geoengineering. Some of the approaches and some of the technologies that have been discussed that are really starting to gain some traction. We talked about those a little bit earlier. So we cover the big and then we cover the small. Again, to educate and to provide professionals with a background into these technologies and where these are going. ESG as well has really taken over a large role in the business community, not only directly for the financial and the accounting folks, but also for people that consult, engineers and technicians as well. We all work together. So having first a basic understanding and a way to kind of integrate ourselves into that, where with ESG reporting, how we can perform our work better, not only for our individual companies and institutions, but also those that we serve. And then again, pulling it all together, how these work together, demonstrating through case studies. Imitation is the sincerest form of flattery in many ways. And so by providing case studies, how resiliency and sustainability is incorporated in the case studies into some of these large engineering projects that we have in our Chapter 21, our case studies section, is very important to demonstrate how these can be used and how practitioners can incorporate these principles and these approaches into their work. Also from a short course standpoint, Dr. Reddy had talked about how this becomes a valuable resource for on the academic side for university courses. For more of the professional approach with short courses, this is a very good reference and serves as a great benchmark and a great basis where short courses can be taught or participated in by practitioners. It allows for an explanation of those base core concepts that allow people to speak the same language, have an understanding of how these approaches and concepts affect practice, with the demonstration of the various assessment tools across the realm of resilience and sustainability. It becomes important because then people are able to see practically how these theories are integrated and used in real world problems and tackling real world problems. The way we lay out the materials too facilitates one-on-one and group discussions about the concepts, looking for greater solutions that all that participate in a short course can look to serve their practice and serve their clients better. And with that, I'll turn it over to Professor Reddy.
Very good. So this is the last slide. So kind of overview of what we covered. We showed you the survey results that clearly demonstrates the need for teaching a course on sustainable and resilient engineering. And, our book will address all the challenges and barriers that were identified in the survey. And we have provided resources for instructors. We try to make their life a bit easier. We have PowerPoint slides that can be modified and tailored to your needs. And we have the numerical problems at the end of each chapter, and we have a solution manual for that one that you can download from publisher's website. And we have a lot of examples on sustainability assessments. So it's a great textbook. And as Jeff, explained in detail, how this could be a great reference book for professionals who wants to advance their knowledge on sustainability and resiliency, not only advancing the knowledge, but actually implementing the stuff in their project. So that is that's what we wanted to cover, and I hope it was informative about what this book entails. And as I mentioned, book is released today, August 19th, and it can be print from the Wiley Publishers website or Amazon or other online sources. So